Hey Math 1, we've got a new video for you. 4.5, it's pretty much the same thing as 4.4. There's no new notes on this video, but I am going to work through 2, 4, and 6, giving you half the answers to your homework tonight. Sounds good? Okay, let's work through number 2. All right, back in 2010, a Randall Miller baseball card worth $45 gains kind of a weird rate of change, $3.50 every 10.5 years. Of course, I made this up. I just wanted to kind of use a situation like increase of value appreciation. So the first thing we're going to do is we're going to write an equation representing the value of the baseball card. So the first thing we need to do is define our two variables. So we've been using x and y. Seems like that would be a good one to go with. Now the two variables we have are given in the rate of change. The rate of change is $3.50 for every 10.5 years. So our rate of change is going to be $3.50 divided by 10.5. Now, if you remember from the previous video, the rate of change gave us our y divided by our x. So the y represents the value of the card in dollars. All right, hopefully you guys can see that whole thing. Yep. And x is usually the time value, time in years. So that's the first thing I want you guys to do, is define your variables. Now, keep in mind that this is the third time we've talked about writing linear equations and what it looks like. It's still the starting value or the starting point. And then based on increase versus decrease, we're going to add or subtract the fraction rate of change times x. So if you're still baffled about how to write equations of lines, this is the model we're using every time. Okay? So what's the starting point? A Randall Miller baseball card worth $45. Okay, that's the starting point. Gains in average value, so gains would be plus $3.50 over 10.5x. Now, you know what? I don't like decimals and fractions like that, especially 3.50 over 10.5. So what I'm going to do before I plug it into my equation here is I'm going to say 3.5 is the same as 35 on top if I divide by 105 on the bottom. So I multiply top and bottom by 10. Yeah, and it just so happens that both 35 and 105 divide 35. So 35 times 2 is 70. Add 35 more, you got 105. So this, the top goes into the bottom 3 times. So divide the top by 35, you get 1. Divide the bottom by 35, you get 3. So I want you guys to put the reduced version of the fraction inside your equation. So that's the answer to part A. Now what do we do with part B? Well, part B, we first rewrite the equation because we're using this equation for all parts. 45 plus 1/3 x. In what year will the card be worth $80? So we are given a dollar amount, $80. Which of these variables is dollars? It's y. We're given y equals $80. So we're going to take the y out of here and replace it with 80. Okay. Get x by itself. I'm going to move the 45 to the 80. $80 minus 45 is 35. How do I solve an equation with a fraction in it? Well, I can find a common denominator. If the bottom's 3, just multiply this by 3. And we just talked about the fact that 35 goes into 105 3 times. So 3 times 35 is going to be 105. So 105 over 3 equals 1x over 3. Yeah, and then once you find common denominators, you can ditch the denominator. So, 105 equals x. Now, this doesn't quite answer our question. In what year will the card be worth $80? I don't think it's the year 105 AD or 105 BC. What it's saying is 105 years later than the original date that we're talking about. So what you're going to do is you're going to say the year 2010 plus 105 years, that's going to be the year the card will be worth $80. So the year 2115 AD. Okay. Let's try part C now. Well, we start with our equation like we always do. Every time you do part A, you're using part A to find the remaining values. How much will the baseball card be worth in 2025? So, 2025 represents 15 years after 2010. All right? I'm not just going to straight up plug 2025 into this formula right here. Really what's happening is it's saying that the card is 15 years older than it was in 2010. So that's what I'm plugging in for X. 15 years goes in for X. Yeah. So Y is equal to 45 plus 1/3 times X, which is 15. Now, quick review. How do I multiply a fraction times a whole number? I'm going to put that whole number over 1. See if some cross cancellation can happen. 3 goes into 15 5 times. So it's 1 times 5 over 1 times 1, which is 5 over 1, which is 5. Y is equal to $50. Yeah, so the baseball card is projected to be worth $50 in 2025. All right, number 2, complete. Number 4. We're talking candles now. Let's see, maybe I can put some more room over here. Oh, this is going to be tricky. Come on now, we can do this. If we put our minds together. All right, I think we got it. A large candle 18 inches tall burns at an average rate of 2.4 inches every 2 hours. Write an equation to represent how tall the candle is based upon the number of hours it's been burning. All right, so first thing we're going to start with is an X and a Y value. Remember, X is usually time if time's involved. Boom, we got a time value right there. It's going to be time in terms of hours. And then the only other unit given to us is inches. It's the height of the candle. So, how tall the candle is. You know what? It's height of the candle seems like a way better way of talking about it. Much more elegant. Height of the candle. That's going to be in terms of inches. Okay, so part A requires us to define our variables. Then we have to use y equals the starting point. In this case, we would be subtracting because the candle wax is burning. And whatever our rate of change is. Make sure we multiply that by x. So, y equals, the candle starts at 18 inches. We're subtracting 2.4 every 2 hours. Now, before we move forward on this, I think it would be the best case scenario to simplify that just like we did on number 2. So 2.4 over 2 is the same as 24 over 20. And if you cut that by, looks like they both divide 4s. Divided by 4, you get 6. Divided by 4, you get 5. 6/5 is probably a better way of talking about this. So there's part A. There's the equation that we're going to use to solve both B and C. All right, so how tall will the candle be after burning 12.2 hours? Well, I mean, we're using y equals 18 minus... You know what? Because we have a decimal here, I'm thinking it might be a better way to talk about 6/5 as a decimal, okay? So 6/5 as a decimal is going to be 1.2. Okay, so I'm going to replace 6/5 with 1.2. And now we're going to say 12.2 hours is the given. X is hours, so we're going to plug in x equals 12.2. Now the great thing about this one is I really wanted you guys to get some practice again with multiplying decimals. I know we haven't really done it a whole lot since that very first chapter, but we have reviewed it several times since then. So you got to take 12.2 times 1.2. How do we multiply decimals? Two times 2 is 4. 2 times 2 is 4. 2 times 1 is 2. Drop a 0. 1 times 2 is 2. 1 times 2 is 2. 1 times 1 is 1. Add the columns. 4, 6, 4, 1. 2 digits of decimal accuracy to the right means you come 2 digits to the left at the very end. That's going to be 14.64. So you're going to get y is equal to 18 minus 14.64. Okay, you know how to multiply decimals. Do you know how to subtract them? Well, the stacking is important. You got to put 18.00 minus 14.64. The decimals need to be stacked when you subtract. They don't need to be when you multiply. So 0 minus 4 can't do that, so it's 10 minus 4, which means you borrowed from here, and we had to borrow from here. It's going to be 3.36. Y is a inch unit, so it's 3.36 inches. That's the height of the candle after 12.2 hours. All right. That was kind of rigorous. We've seen much worse than that though, right? Part C. How long will it take the entire candle to burn? The entire candle to burn. Well, if the entire candle has burned, how much of it is left? There is 0 inches in height of candle. It's just a blob. 0 inches would be a y value. So you're basically saying let y equal 0. And then solve for x. X is a time value. You're basically solving that equation. And you saw that on the notes yesterday. I think it was the Gatorade cooler being empty. You plugged in 0 for y. Same idea here. On that Gatorade example, we added the x term to the left-hand side because you can add anything to 0. And then if you want to multiply, oh, you got a fraction on the left. Let's turn the 18 on the right into a fraction. By the way, do you guys remember cross multiplication? Yeah, we can take the purple 1 times the 6x to get 6x. You can take the 5 times the 18 here, which gives us 90. So you can use shortcuts like that. Divide both sides by 6, and I believe you get 15. So 15, what's the x unit hours? It takes a while for that candle to burn completely. All right. Oh man, 16 minutes. This is taking a lot longer than I thought. That's fine though. I'm giving you guys answers. So if you're complaining about the teacher giving you answers, you need to reassess some things. All right, last one. A 7-ounce bar of soap disintegrates at a rate of 1 ounce every 12 minutes of use in the shower. Let's talk about this. Graph the weight of the soap as it's used in the shower. I do not want you to graph it. We need to get rid of that. Got to make some adjustments before I post this. Okay. This will be part A when you guys see it on the notes document. Part A. We first want to define our variables. Remember, x is always going to be time if time's involved. I see minutes. That's a time variable. The y value is the other part of the rate of change, 1 ounce. So it's the weight of the bar of soap in ounces. Soap weight, and the abbreviation for ounces is OZ. So y equals my starting point, which is a 7-ounce bar of soap. It disintegrates, which means it's going away. 1 ounce every 12 minutes is 1 over 12. Yeah, remember rates of change, rise over run, it's always a fraction if it's the slope or the rate of change. And then you got to multiply that by x. Part A, there's your equation. Part B, after 1 shower, a bar of soap weighs 5.6 ounces. How long was the shower? Okay, 5.6 ounces is a y value. So you're plugging y equals 5.6 in for part B. And then I showed you this little trick on the last video where you can move the x term to the left. Move the y term to the right. You get 1/12 x is equal to 7 minus 5.6. Think of it as 70 minus 56. That's a 14 number difference between the two. It's going to be 1.4. 7 minus 5.6 is 1.4. All right, and now a shortcut. Not really a shortcut. Remember when I first taught you guys how to solve equations? You didn't always have to find a common denominator. You could have just multiplied both sides by the reciprocal. I bit my tongue there when I said sides. The reciprocal is 12 over 1. If I multiply both sides by 12 over 1, I get rid of the 1/12 in front of the x. And 12 over 1 is the same as just 12. So take 1.4 times 12. We got our answer for part B. So maybe I'll go off to the side here. Do some more decimal multiplication. 1.4 times 12 is going to give us 28. Drop a 0. 1 times 4. 1. Okay. 8, 6, 1. 1 digit of decimals means go in 1 digit of decimals. So x is equal to 16.8. What does that mean? It means the shower was 16.8 minutes. Or if you want to get really specific, 16 minutes and 48 seconds. Okay, part C, last one. How much would a bar of soap weigh after a 30-minute shower? 30 minutes. Well, I would use the same equation up here for part C. 30 minutes is an x value. That means I'm taking the x out and plugging in 30 in its stead. So it's going to be y equals 7 minus 1/12, not times x, times 30. Okay? And then taking 1/12 times 30, maybe I'll do some work off to the side here. Put the 30 over 1, cross cancel. Let's see here. If I divide the top and bottom by 2, I get 15 over 6. They both divide 3. Oh, it's just 5 over 2. What's 5 over 2? 2.5, right? It's 7 minus 2.5. So when you think about it, take 7 minus 2. You get 5. Take away half. You're at 4.5. And y is equal to ounces. So after a 30-minute shower, if that bar is disintegrating at the rate that we defined it to be, it's going to be 4.5 ounces. All right. 22 minutes, guys. Thank you for sticking with it. And please complete the odd ones as well. Good luck. Thanks for watching.